Hello everyone, my name is Boris Matijasevic and I work here at HTEC Group as a software developer, and I'm here today to present you with the idea of event sourcing. Event sourcing is an architectural pattern which is mostly concerned with the way we store our data. And we usually do that by keeping the latest state and then updating that latest state. For example, if I want to find out someone's email address and I'm using SQL database, all I need to do is to go to users table, find that particular user and check their email. And if I ever need to update their email, I can just update that single cell. And then I again have the latest state for that user. And that's fine most of the time. But what happens if I need to find out their previous email address? Or if I need to answer the query, what was their email address like 2 weeks ago? Well, I cannot do that with only keeping the latest state, because I don't know what happened in the history. Therefore, we need some form of history of changes. And event sourcing is here to help us with that. And here is how. Event sourcing is not about states. Event sourcing is all about events, the changes that happen to objects. So in event sourcing, we always save events and then we can replay them in order in which they happened for any object, and then we can get that object to any of its previous states, or if we replay all of its events, then we get that object to the latest state. And before we jump to basics, I would really like to point out that event sourcing has not been invented by programmers, and it's been around for quite some time. For example, accountants use event sourcing in ledger books. Also, you can find it in law, in medicine, and any other industry which needs to have a history of changes. For example, you can find such changes in legal books, you can find these in medical history records, so anything which needs to record the history, the way that something happened. Okay, now that we know the idea of event sourcing, let's jump to the basics. First, we need to define what events are. And one way to explain the event is to say that events are something that happened that domain experts care about. And we can see a couple of important things from this sentence. First, we can see that events have already happened. Thus, they are named in past tense. For example, user moved, user got married, user changed their email address, apple fell down from the tree. It really doesn't matter. What's important is that events already happened. And as a consequence to that, they are immutable, because we cannot change the history, as of now at least, because we don't have time traveling yet. So it's done, what's done is done. So they're immutable, and therefore they also cannot be deleted. We cannot neglect the fact that something has happened. So these are some of the most important properties of every event. They happened in the past, and as a consequence to that, they are named using past tense, they are immutable, and they cannot be deleted. Now that we know the basics here, I would really like to mention that first sentence on this slide here was said by or written by Eric Evans in one of his books about domain-driven design, because domain-driven design really goes hand in hand with event sourcing, CQRS, and other technologies and other patterns, especially in big enterprise projects. And I'll later show you an example of such an architecture, but now let's stick with a simple concrete example of event sourcing. So let's pretend that we have a system which uses command pattern. And let's say that first command which comes into our system is called create object. And as a result of command which is named create object, we create an object. For example, a balloon. And that results in an event called object created. What's really important here to note is that commands are named using imperative form, so create object. But events are named always in past tense. So command which is named create object results in event named object created. And then we continue our chain. Next command which comes into our system is, for example, called add legs. And then we add legs to our balloon. Why not? This results in event called legs added. After that, we get add hands, we add our hands, hands added. Add face, face added. Add name, name added. And we added and we named our stickman here Gila. Balloon, stickman, doesn't really matter, but the point is this. From this picture, you can see the biggest benefit of event sourcing. If I were using only the traditional way of storing the data and only keeping the latest state, I would only have access to this latest form here, where this stickman has a name. But since I'm using event sourcing, I can stop at any point from here, at any of these 5 pictures, and I can examine the state of object at that point. For example, if I need third point here, all I need to do is to start with an empty object and reapply object created, legs added, and hands added. And then I have the state of that object at that particular point of time. And I wouldn't have the ability to do that if I were using the traditional way of storing the data. There is one more basic term that we need to define here, and it's streams. So streams are a way to group events. For streams, we can say that they are really timelines for objects, because they represent ordered collections for events which are all related to a single object. And you could already see an example of a stream. So in the previous picture shown here, these 5 events here form a stream for this stickman here. Also, we have a couple of rules in streams. We cannot delete events from streams. I cannot just arbitrarily go here and delete event 2, because I cannot neglect the fact that something has happened in the past. But if a need arises, I can delete the whole stream, therefore pretending that I never cared about this object. Or maybe it's better to say that I no longer care about this object, but that is permitted. So in short, streams are here to group events which are all related to a single object, and they always group them in order in which they happened, so that we can later replay them in that order. Okay, now that we know about events and streams, let's see how do we store them. Well, we store them in databases, of course, but we have specialized kinds of databases which are named event stores. And event stores excel at a couple of things. They're really good for storing events, streams, and they can naturally answer to temporal queries. Temporal queries are specialized kinds of queries which deal with time. For example, how many apples did I sell yesterday? Or how many apples did I sell yesterday between 2 and 4 p.m.? So anything that has to do with time. Any database can act as event store. SQL database, NoSQL database, caches, event buses. Kafka is really often used as event store. But we have some event stores which are built, or let's say we have some databases which are built from ground up to act as a natural event stores. And the most famous example of them is event store, the event store. So yes, the most famous event store is the event store. Who would have guessed, right? And I would really like to recommend their website, since not only it contains documentation for event store, but it also contains a lot of good articles related to event sourcing. For example, I would really like to recommend any article written by Alexei Zemarev or Greg Young, since I really like their way of structuring the code and the way that they explain event sourcing. Now we know where we are storing events and streams. Now let's see how do we add a new event. This is more of a theoretical presentation, so I'm not going to show you here concrete code examples, but you can find them on event store website or other sources on internet. But I'm going to provide you now with the idea, and then you can write the concrete examples of code after this presentation. So let's pretend that we need to add a new event here. First, we start with an empty object. If we are using object-oriented programming, we create an empty object of a class for which we want to add new event. Then we load all objects from we load all events for that object, and then we apply all of these events for that object in order in which they happened. And at this point, we now have this object at its latest state. Then we try to apply newly created event. And I specifically here say try, because this is usually the place where we do our validation. And should that validation succeed, we then add that new event to the event store. As long as event sourcing is concerned, this is all we need to do. Immediately after this, we can dispose of object if we want. We can send it to further calculation. We can do whatever we want with that object. But for event sourcing, what really matters is that we added a new event to the event store. And this is the whole flow of adding a new event to the object. But before we move to the next topic, I would like to point something interesting here. Let's look at the third bullet here. It says apply all loaded events to the object. And it's not really a problem if we have like tens or hundreds, even thousands of events. But what happens if we have millions or billions or trillions of events for an object? And that really can happen. For example, if we're creating an event sourcing system for airports or public transport or anything which has to deal with a lot of data. Well, we have a couple of solutions for that situation. And depending on our needs, we can use some of them. So let's present two of such solutions. First would be read models. Read models are models which are optimized for reading, like their name implies. And they're used when we need to display the latest state for an object, or we need to send that latest state to an external system, external API, for example. We can have multiple read models in our system, and each and every of them are optimized in their own way. But all of them are subscribed to an event store. And in this situation, event store remains as a single source of truth. So, like shown on diagram here, I have NoSQL database, and Redis cache. And in these, I keep my read models. And they're all of different forms, and they're all subscribed to event store and pull data from event store. And I can freely dynamically add, change, or even remove read models, but event store acts as a single source of truth in this situation. So these read models are just subscribed to event store. Another technique that we can use for a very similar situation is to use snapshots. Snapshots represent checkpoints for events after a certain number of events. And we usually use snapshots when we want to recreate the model, but when we want to add a new event. So if you remember the flow from a couple of minutes ago, I need to put my current object to its latest state, and then I can only add the new event. So this is what snapshots are for. Now, before we jump to theoretical explanation, let's see a more concrete example. If you remember from my first slide, I was explaining that accountants use event sourcing, and they use it in their ledger books when they keep transactions. And an example of snapshots can be seen that accountants often create that snapshot of a state or checkpoint of a state on the 1st of January. And for example, if we want to find out our current bank balance, we do not reply all transactions which ever happened. We just reply transactions which happened in this year. And that would be one concrete example of snapshots. We can do it every midnight, we can do it every 1st of month, it doesn't really matter. But what matters is that we capture the state of ledger book at a certain point of time. What's really important here to note as well, before we jump to the next example, is that snapshots are states. And snapshots are just supplementary to event sourcing. They're not a crucial part of event sourcing. Because we said that in event sourcing, we always store only events and not the states. And snapshots are states. Therefore, we keep snapshots in a separate database, which is called snapshot database. And again, you can use whatever database for that purpose you like. It's all up to you. Let's see snapshots in action. For example, let's pretend that we have a stream of events and that we have 8 events in that stream. So that events slowly start piling up. For example, event 1, event 2, event 3. And at this point, I decide that this is really enough and I want to create a snapshot at this point. So I do that. After that, we have event 4, event 5, event 6. And again, at this point, I want to say, okay, it's enough, we need another snapshot here. Okay, fine. After that, we get event 7 and event 8. And let's wait a couple of, doesn't matter, hours here. And let's say that now we need to add event 9. And let's pretend that these event 8 are really computationally heavy. And we do not want to reply all of them just to add event 9. So what we can do in this situation? Well, luckily, we're using snapshots. So let's start with an empty stack. And let's start popping things from the end of this string until we reach the first snapshot. Here we have event 8, then we get event 7, and then we reach snapshot 2. And this is everything that we need. So now I have a stack structure here consisting of 2 events and 1 snapshot. What I now need to do is to create an empty object. Then apply that snapshot, then apply event 7 and event 8. And here you can see that I have the latest state for this object with only 2 events applied. This is how we can really speed up the model recreation, and now I can freely add only the event 9. Okay, so that would be those 2 techniques. So read models and snapshots. Depending on your need, you should choose between those 2. Now I promised an example of an architecture, so let's see it. Let's pretend that we have our system and we have external system, represented here by Gil of course, and let's say that external system wants to change an object within our system. In order to do that, external system issues a command to our system. That command is received by command handler, which in turn immediately returns the response 202 accepted. If you're using REST, of course. If not, you just need to return any form of accepted response to the external system. After that, command handler can do multiple things with that command. It can do whatever it wants. It can process that further, but among other things, and what's really important for our story here, is that it will create event from that command, and it will send that event to event store. Later, let's say that external system wants to find out about the latest state for an object which it previously sent command for. Therefore, they issue a query to our query handler. Query handler goes to our read model. Read model then returns data to query model, which in turn returns data to our external system. And 2 things can happen at this point. External system will either see the latest change being applied or not. And here is why. It's due to this link here at the far end between event store and read model. It's because that link is asynchronous. Read models are subscribed to event stores and they pull data from event store, like we said. But that change doesn't happen immediately. And if external system queries the system too quickly, they will not be able to see the latest change applied. For example, you can see this phenomenon also on Azure portal, where you would create a resource, and if you refresh the page too quickly, you will not see that resource created, because Azure didn't have enough time to react on that command. But if you refresh that page a couple of seconds after that, you will see your resource there. That phenomenon is called eventual consistency, because it says that our system will eventually be consistent, just not right now. The left part of this diagram, consisting here of command handler and query handler, is something which is called CQRS. CQRS is a pattern where you separate your commands from your queries, so reads from writes. And it's often used with event sourcing. Command handlers and query handlers can be created using domain-driven design or any other similar design. So this is the example of how you can combine those 3 in an architecture. Then again, to suit your needs, you can further increase the complexity of your system by adding event buses and further processing of these commands, or just adding multiple read models which can all be optimized for different reads. Next thing I want to mention about event sourcing is regarding testing. Testers really like event sourcing, and developers when they are debugging. And here's why. You know how testers often report situations where objects are found in inconsistent state in database. And we usually don't know why. The first thing that we check is audit logs. But audit logs are incomplete. They do not contain everything. Whereas event sourcing keeps track of complete history of changes. And here's how we can debug that situation. We would start with an empty object, and then we would apply a series of events in order in which they happened until we reach that inconsistent state. And the latest event that we have applied is the culprit for the current situation. That's how easy it is to debug the situations using event sourcing. Now, before we end this presentation, I have a couple of questions for you. The first question would be about erroneous events. So we just mentioned during the testing that it can happen that we get wrong or entry suite errors in our system. So how do we deal with that situation? Remind you, we cannot delete events, we cannot change the events, we cannot change that something has happened, but we need somehow to correct the state. So how do we do that? The next question would be about eventual consistency. So you remember from architectural diagram, we said that link between event store and read model is asynchronous, and there it happens that we have eventual consistency. So how much of it is a problem, or is it a problem at all? Is 1 nanosecond of eventual consistency a problem, or 1 minute is maybe sometimes enough? That's an open question. Next question is about concurrency. So what happens when we have 2 events or multiple events coming in at the same time? Do we discard some of them? And if yes, which one should we discard? And if we apply all of them, in which order do we apply of them? Do we again apply validation, or how we generally deal with that situation? And the last question from me to you is about GDPR. So you know how a main point of GDPR is right to be forgotten. And we said that we cannot delete events. Well, sure, we can delete the whole streams, but that's usually not what we want to do, because we want to keep some record of that stream. But then how we can apply to GDPR? Okay, so this would be my questions to you. Now I would really like to hear your questions regarding event sourcing, and you can reach out to me in the QA session. You can use this silly form like I mentioned here, or you can ask verbally your questions. Thank you for your attention, and thank you for being a part of this event.
Hello, hello. Can you hear me? Hello. Hello, Boris. Hello, Alexander and Dusan joining me. And Boris, we had a great presentation. You know, I really enjoyed this. Maybe I'm not such a techie guy, but I remember when with my kids when I play this Hangman, you know, and I have to tell them this event, you know, that's really how to develop. You know, maybe they will become coders. You know, learning from you, Boris. Your inspiration with this tech forward talk. A few questions for you, Boris. Since you're a great engineer in HTEC Group, you know it's really interesting to hear from you. You know how this all started. Can you tell us, you know, something about your beginnings and what made you choose actually to become engineer? Was this really top of your mind in early age?
Well, thank you, Nico. So like you mentioned, yeah, it really started from my when I was young, when I was a kid. So I always like to tinker with technology, with machines. I liked really everything that's connected to machines. And then at a certain point of time, my family bought us a computer, and I was fascinated by that machine. And yeah, then I started clicking, and I think I opened every single folder in that Windows XP. I tried to do every command. I'm not even sure how it didn't flame up at a certain point. And then I think I opened everything. I think that I tried everything after a couple of months. And then I thought to myself, hey, yeah, I tried that. I thought that's almost everything from that computer. But what if I can do something new? And then I heard of programming, and it was a strange concept to me back then, since I was really young at that point. But then I learned, hey, yeah, there is a thing called programming, and it will let me to teach a bunch of screws, motherboards, plastic, memory. It doesn't really matter what our computers consist of, to do what I really like. Wow, that's really a great idea, great opportunity there. So, okay, well, what should I create first? Well, let's learn how to create a quiz. So I had a couple of my friends come over on the weekend, and I presented to them a silly small quiz with 5 questions created using a huge switch statement. Well, developers will know about that. So yeah, and it actually worked. Then yeah, I was amazed by it. And then a couple of days later, I said, well, if I can create a quiz, I can create something which is really powerful. So for example, what if I enter a number and the machine can tell me if it's a bigger or smaller than that one? And that was like a boom for me. So so that's how a single kid was really amused by a technology, and I continue improving on that part. And this is where I am teaching computers how to say which number is bigger than the other.
Good. Great to hear. And I will have a few more questions for you, of course, because it's in HTEC, you usually say, delight, not just deliver. So maybe here's also a question. How do you translate this from your perspective? How do you develop this passion for programming and software?
Yeah, in my honest opinion, it's really important to love what you're doing. So it's not just to deliver, like you said. It's not, hey, I know how to do this. Let's do it like we did it 100 times before this. So we always need to improve on the process. We always need to find out how to do some things better. We need to learn from our mistakes. Of course, as little mistakes as possible, that's okay, but to learn not to repeat them, to always improve, to always optimize. And honestly, to me, coding and programming is sort of art to me. So you need to define it, to look good, to be proud of it, and and make clients proud of our work as well. And when you, as a developer who create that code, you can look at it and say, hey, this is really great. I'm really satisfied with that. That's really what's important for me.
I remember also the slogan, "The art of possible," and I know one great tool actually having art as inspiration to the top leaders way. So for me, it was pretty strange at the beginning. What's the painting has to do, with
Yes.
leading people or managing it, and then it's reflection and art is coming. Actually, there was even a book Nancy Adler wrote about how we can use inspiration from art, and actually it's interesting to hear, also tech get on the level of the art, art of possible.
Yeah, for me, really, coding is a form of art. So maybe not everyone agrees, but yeah, it's creative. It shows your inner feelings in a sort of way. So yeah.
And sometimes nobody's perfect in a way. So sometimes you also feel unsure maybe about how to achieve the goals of the project you're working on. What do you do in these cases? You test and try, you look for best practice, you call your colleague, like Dusan, Alexander.
Well, yeah, I would say depending on the situation. So, to be honest, nothing works from the first time. Maybe once in my life it happened that I wrote like 300 lines of code and it worked. Maybe once. So you always have something to learn from that experience and to improve. So if I'm in a situation where something is not working out as I would really like for it to work, then I ask always my colleagues, my peers, and then we try to brainstorm together to see how we can overcome that difficulty. And if that really doesn't help, then Dusan and Alexander here, they're the first to listen to us, and then they try to find the other colleagues within HTEC who can really help us, and then they connect us, and then we ask them for a solution. And it really doesn't matter if they're not the experts in that field. If they are, that's great, but if they are not, then we always have people who we can ask, and then we can consult, and we can brainstorm together. We also ask clients. Sometimes they connect us with other dependencies, and there is always a way. If you want to find a solution, you'll find it. That's for sure.
That sounds great. It reminds me, when we were younger, before we get married, and before Corona, of course, and actually looking for a nice girl, going for dating, it never works in the first time, but you talk to your colleagues, it's just benchmarking in a way. So. Okay, so I will let Alexander and Dusan ask for more technical questions. Let's go deep in tech now. Who would start? Alexander, maybe?
Regarding the technical things, I think that we already have some questions on the Facebook and LinkedIn. Maybe we can start with that.
Fantastic. Okay, just double check. See, how can we add event sourcing to an already existing system? Does it help the system is already using CQRS pattern?
Okay. how can we add event sourcing to an already existing system? So yes, it's, in my opinion, it's always easier to add it from the beginning when you have event sourcing in mind. But I guess that it can happen that sometimes you need to add it in already existing system, which is not already using it. So in that case, well, it's not a small change to begin with that. You need to prepare a lot of things there. It changes the way you persist things in your database, the way you persist them. That's the biggest change. And so I would start by asking myself, do I need to event source everything? And then I would define a subset of my system, which I need to be covered by event sourcing. And from that point, well, we do not have the history of changes prior to that point. So we really need to start fresh from that point. And we can create, for example, initialize object initialized or something like that events, and then we can start from that. And that event would bring all currently existing events into event store with that base level. And from that, we can define further events and we can start piling them like we already use event sourcing. Sadly, we cannot know anything about the history from the previous times, but from that point, we can start adding new events and know about the history. And regarding the CQRS, well, event sourcing can exist without CQRS, but they go naturally hand in hand. So yes, if you plan to already also include CQRS while adding event sourcing, then yeah, it already helps because it's already there. But I think that you can add it even without CQRS and everything would be fine. So the major factor in there would be really a repository layer. And if you layered properly your application, then domain and APIs or everything really doesn't have to change on the repository level. Yeah, I hope that answers the question.
Okay, and Milenko is having another question for you. Are event sourcing and event architecture similar?
Well, they both do with events. They are similar in that way, but they try to deal with different problems. Event sourcing has more to do with kind of persisting the data in your databases, and event-driven architecture is more of a way of communication between your components, between your microsystems. So in event-driven design, in event-driven architecture, you publish events and then you react on that events, and that way you can create asynchronicity in your system. You can have multiple different components react on a single event, and that's how you maybe you can see those events more of a signals or notifications than as an events, and then others can react to that events and do something. Whereas in event sourcing, the accent is on saving that events in our event store. So yes, there are similarities, but there are substantial differences.
Okay. And there's more questions now from Nicola. How long do we keep events and snapshots in an event store?
Okay, so I think I mentioned in one slide that we cannot arbitrarily remove events because we cannot neglect that something has happened in the history. So as long as I care about aggregate, if speaking about domain-driven design, I cannot just remove arbitrary event from it because I cannot neglect the fact that something has happened for that object, for that entity. But I can remove the entire stream, pretending that I never cared about that object. So as long as that object is alive, as long as we care about it, we must not remove any event which is related to that object, and not even the latest one. There's no removing events whatsoever in that point. But if we want to forget about that entity, yeah, we can then remove the whole stream containing all events in that situation, and yeah, those events can be removed. We usually don't do that. We usually just obfuscate the data because we like really to have records that something has happened in our system. But regarding snapshots, I would say that you can safely remove previous snapshots and you can always keep only the latest one, because you usually, let's say 99% of time, you really want to have the latest state of an entity. So you really want to keep the latest snapshot for that entity. But if you what just occurred in my head. If you want to move that object to a specific point of time, and you have some other snapshot which is really close and happened before that point of time, and you use that query a lot, then keeping all snapshots can really speed up data. Maybe something similar like adding indexes in SQL database, so you can keep some other structure to speed up your model creation and speed up some other queries.
Okay, let's go forwards. We have more. Yelena asking how to test a system which uses event sourcing.
That's a huge topic, and I think that it deserves a presentation on its own. So when you say test, I can think of a lot of different situations here. So for example, as a developer, what first crosses my mind is unit tests. So yeah, you can create the unit tests for your code, mainly for repository here, the same way that you would do for any other storage. It really doesn't change here. Use AAA or when given, then methodology, it's totally okay. But I would say that it gets a little bit interesting when it comes to integration testing on functional or end-to-end testing. So here, for integration testing, we can test whether when an event is saved to event store, and we can use the actual event store, and we can then pull from it, ask event store, hey, is this event really saved in there? If yes, then that's okay. We can get it back, and we can compare things which we want really to be saved, and if they're equal, then it's really okay. For end-to-end test, I can say that yeah, we can, because we mentioned read models in our system. In CQRS, we would query read model, whereas we would write into a event store, and you can create a test which goes through the whole flow. You can send an event to be saved in our system. You can even start by sending a command. Command creates an event, it gets saved to our database, and then after a certain delay, due to eventual consistency, like we mentioned in architectural diagram, you can wait a couple of seconds, minutes, whatever it does for you, and then you can query the read model and expect and assert that read model is in a state which you really want it for it to be. And if that's okay, then that's it. Regarding the testing from testers, if they are doing manual testing, there is nothing special about event sourcing. It's just a way of persisting the data. So you would test your application like you normally would. And I think it holds true also for automated testing there.
As a professor in MBA, I would say you pass, with all the questions, with all the, if this would be exam. But now we have a few more questions also for Alexander and Dusan, that you don't massage you so much, Boris, with all the questions. Okay.
Okay.
So let's go with Alexander, for example, to start. What are the different parts of being an engineering lead? How do, it's not easy to be a leader. How do you motivate them? How do you lead through change, and how do you see this?
From which to start? There is no other easier question to start some kind of warm up, or I need to answer to this. Yeah, just joking. Yeah, here in HTEC, for example, as you mentioned, the role of engineering lead consists of responsibility of in general three things. I would say that the delivery as a part of it, people management and account management, of course. And I will be honest, there is no easy parts here. On the account side, you need to establish confidence with the clients, to understand their pain points, to help them to grow together with you, of course. From delivery part, yes, you should be sure that every release should be on time with good quality, and to of course, to on time to detect that if something goes wrong, to raise the flag, to do your best together with the team, and to bring a project on right track if something's go wrong. But yeah, if I need to measure those things, those two parts are easier part, I would say. People's satisfaction is something that should be on the first place, no matter what. I give my best that my people or the people in the teams that I'm responsible for are happy working for HTEC. And there is no compromise about that. They need to be happy. But of course, there is a lot of challenges there. Everything starts, I will say, with understanding all of them. It will be the best to establish the personal connection with each of them, to understand them and to support them what they need. But honestly, we need to be realistic, not to give them impossible promises, and to bring them a little bit down to the earth from time to time when that needs to be done. Those guys are actually some kind of your family, because we probably spend more time together with the team members than with some of our family members. I would say something like that. But in the end, I believe that everything starts with being honest and being with them when it's most difficult, no matter is that professional or personal plan. You're one of them, of course. And when you establish that kind of connectivity with your team, I think that all you together can manage everything. That's actually some kind that I want to answer, how to motivate them, how to lead to the challenges. Actually, you are part of the team, and if you are a really good team, you can manage everything.
Great. I mean, it's really, if you think now when we cannot travel a lot and we work remotely also, work, even sometimes in the same room, actually a large part of our life, even 24 hours sometimes. And the only way to be truly satisfied actually in this work is to do what you believe it's great work, to do the best you can. The only way to do great work is to love actually what you do. And you put it nicely, huh?
In some earlier ages, I would say that I'm giving my best that people comes to work happy, but that means staying at home as well.
As well, yeah. So remote and happiness is not connected just to space, yeah. So even with the office with the pool, it's not making you happy if you're not doing what you like. Yeah.
I agree with that.
One for Dushan. Now let's go. What does the selection process, for example, for QA positions look like? This is like commandos in a way in programming, if I would put it this way. How do you see this?
Well, yes, really nice question. Since I have around 10 years of QA experience, and I'm also involved in QA manual interviews, so I'll try to explain the process and to clarify the things. So as soon as somebody applies for a manual QA position, there will be organized a meeting with talent acquisition team, and afterwards, candidate will get 2 days to do a task. As soon as task is done, it will be checked by our interviewers, and if they see that candidate have QA mindset, they will ask him or her for a technical interview. On technical interview, candidates can expect a very nice atmosphere where we are going to get know each other, to do at least one more task, sorry for that, and to answer on all candidate questions, or at least try to answer all those questions. Since I guess the task is something which mostly stress candidates, I'll try to explain it a bit. Task is not a check if something is true or false. It is a check of candidate mindset, nothing more, nothing less. So no need for stress. They just need to show their way of thinking. So that is in short about the process for QAs. Sorry, I can't hear you. You're muted.
That's most common, in last 2 years, you're muted. I should put on T-shirts. It happened to me so many times. But it's another one for Dushan. Maybe just to add here, is there any advice that you would give to people that apply to work? There's a big selection process in HTEC. It's very strict, and a lot of seniors are included, in this process. So, is there any advice how to apply, or what should people do to be accepted, to be better at the interview?
Yes, I understand. Well, it's I'll be really short with this one since I think it's straightforward. Just give your best, show your knowledge, and you will get the best from HTEC and even more. It's simple as that. So there is nothing special. You just need to show your knowledge and be your best version.
So benchmark yourself with the best, and
Yes.
forget the rest. Yeah. Good. Thank you, Dusan. Alexander, I have more question for you. One more. How does HTEC support, for example, your professional, but also, for example, personal growth? There's a lot about growth. Grow yourself by growing others, and a lot of talking about growth. Even companies growing fast, but I see this growth is also coming in a way from the inside. How do you see this perspective? Yeah.
Yes, we all know that IT is going very, very fast, and you need to be up to speed and to follow the latest things that happen if you want to be competitive on the market as well. And I would say a lot of things that HTEC do, how we can all together grow in that educational way. We here organize the internal presentation workshops. We have internal conference last year. We organized winter and summer schools. We also have developed the mentorship program, and so on, additional internal things. But on top of that, we also support all our employees to use some online learning platform as Udemy, or support employees to attend some different IT conferences, or studying for the different certificates that they are interested in. But besides that, we in HTEC develop our competency framework for all technology that we are currently using in the company. There is 4 different levels: inter, junior, major, seniors, with the marks as in progress, meet, and exceed, which lead us to almost 12 different levels of knowledge. And what is the important part here, that after we determine this your level, and in that participating not just your superior but also your peers and people who are on a daily basis with you, together with you in code, in testing, and know you the best. When we calculate all those results and got your exact level, HTEC offers to you the personal development plan, how you can even go further and learn additional things that you're missing in the moment. You are receiving proper learning materials, and it's I'd say personalized for every of our employees.
Okay, and one more for more. We are going slowly to an end. It's like a school hour, 45 minutes. We have to squeeze it. As professor, everything is like school oriented. So, but Boris, should be for the end. In a way, what attributes do you need to have to be successful at your job? You're asking you so many questions. In a way, it's up to you, to demand, that you can achieve these great results, to do your great job, to show which attributes are most important to you to help you.
Well, we partially answered that question already when we started our meeting, but I would really like to add that I guess that you really need to be curious about things in our profession. So you really must never stop learning. You should never get to the point to say, hey, this is enough. I'm satisfied with what I'm doing here. I'm satisfied with what I am, and that's it. And this is where I'm going to stay for next decade or so. No. You should never be satisfied with what you achieved at that point. It's okay to be proud, of course, but you should always strive to improve yourself. You can always be a better version, and every day you should be a better version of yourself from yesterday. I always like to really tell to other people, hey, on Friday evening when you finish your work week, ask yourself, did I learn anything new this week? Am I richer for any experience, technical, non-technical, anything related to the job? Can I do anything better the next week than what I did this week? If answer is yes, then that's really what I'm satisfied with, and that I can continue in that approach and to go with that. So not to be satisfied with the amount of knowledge I have, but to be satisfied in a direction which I go. So always keep improving yourself, always curious, always try to be better version. That's what I really like to add.
Fantastic. And with HTEC, I mean, it's really interesting that it's not only about deep engineering. It's not only about engineering, but it's also about bringing the creativity. And when creativity and engineering meets, that's called HTEC. Right? So. Great, guys. Thank you for sharing all your knowledge or your questions. If there will be more questions on the people watching, more than welcome to share on our LinkedIn, Facebook. I'm sure Boris, Alexander, and Dusan will be ready to give you some more insights from HTEC and from their personal engineering career. Thank you, and see you soon on Tech Forward.
Thank you.
Thank you, everyone.
Bye-bye.
Bye.
Bye.